Welcome back, science fans. In the near future, humanity will take its first steps onto an alien world. But instead of waiting, let's embark on a journey today to the distant world of Jupiter and explore the science and technology behind such a mission. The year is 2061. Earth's nations have come together under a global space organization, pooling their resources to allow humanity to reach farther into the cosmos than ever before. New propulsion systems, like ion thrusters and nuclear propulsion, have been developed, reducing the travel time to other planets and making interplanetary travel possible. Advanced AI systems are integrated into the spacecraft, assisting with navigation, diagnostics, and even the crew's well-being. The crew is comprised of 6 astronauts, each chosen for their unique skills and knowledge. Their mission: search for life under Europa's frozen subsurface ocean. Europa was chosen for a reason. In 2013, NASA announced that researchers using the Hubble Space Telescope found evidence that Europa might be actively venting water into space. This would mean the Moon is geologically active. Life as we know it seems to have 3 main requirements: liquid water, the appropriate chemical elements, and an energy source. With this mission, scientists will finally be able to validate this theory. As the world watches, the Starship Enterprise embarks on its ambitious journey. Yes, folks, that's a Star Trek reference for all you Trekkies out there. Constructed in orbit, the spacecraft represents a new era in construction, where ships are built and launched from space to overcome Earth's gravity. Traditional rocket launches from the surface must reach an escape velocity of 25,000 miles per hour. However, since the ship is already in low Earth orbit, the required speed is slightly less. Aboard the Starship, the crew watches the breathtaking view of Earth as it gradually shrinks into the distance. They marvel at the vibrant blues of the oceans, the swirling patterns of the clouds, and the striking greens and browns of the continents. Earth appears fragile, a peaceful oasis of life amidst the cosmic void. We're reminded of the pale blue dot, a famous photograph of Earth taken by the Voyager 1 spacecraft in 1990 from 3.7 billion miles away. In that image, Earth is a mere speck, a tiny pale blue dot suspended in a sunbeam. Soon the ship passes the Moon, and the crew watches as it comes into view. The Moon's cratered surface is clearly visible. It's incredible to think that the first Apollo moon landing in 1969 was barely 100 years ago. In 2023, a journey to Europa would take 6 to 7 years. But in 2061, it could be reduced to 24 months, thanks to advances in propulsion technology. But the Enterprise will also employ an age-old trick, a gravity assist maneuver around Venus to accelerate its speed. In a gravity assist or slingshot maneuver, a spacecraft approaches a planet and uses its gravity to alter the ship's trajectory and velocity. As the craft nears the planet, it experiences an increased gravitational force that pulls it closer. This force accelerates the spacecraft, effectively slingshotting it away. The science behind a gravity assist is the conservation of momentum and energy. As the ship gains momentum and kinetic energy, the planet loses an equal amount of each. But because the planet is more massive than the spacecraft, this energy exchange has a negligible effect on the planet's motion, but a significant effect on the spacecraft's trajectory and speed. Once they leave the Earth-Moon system, the astronauts settle down for a long journey. Much of the trip is automated. The ship's onboard systems regulate the environment. Artificial gravity is provided by a rotating habitat module, a concept first proposed by German scientist Wernher von Braun. The ship's lighting system mimics Earth's day-night cycle, which helps maintain the crew's mental well-being. To stay fit, the passengers participate in high-intensity workouts, zero-gravity simulations, and specialized exercises designed to strengthen muscles. Meals are made up of pre-packaged foods, hydroponic technology, and lab-grown proteins. The hydroponic module uses nutrient-rich water and LED lighting to produce fresh food. The proteins, which are cultivated meat, are made on board using a combination of muscle and fat cells derived from animal sources. These meals are indistinguishable from traditional meat and are vacuum sealed to be easily prepared using the spacecraft's microwave. The hydroponic module not only provides the crew with essential nutrients, but also purifies the air and provides a psychological boost by surrounding the passengers with plant life. In about 6 months, the spaceship approaches Mars, and the crew marvels at the red planet. Its rust-colored surface, a result of iron-rich minerals, contrasts dramatically with the darkness of space. High-definition video allows the crew to study the planet's most notable features, such as Olympus Mons, the tallest volcano in the solar system, and Valles Marineris, a vast canyon system that stretches for thousands of miles. As they speed past, the crew reflects on the ongoing efforts to colonize the planet. Terraforming Mars has been a dream of humanity for decades. You can click the link above to watch where I discuss this in detail. Time passes, and a few months later the ship approaches the treacherous asteroid belt, a vast expanse of space rocks between Mars and Jupiter. The most accepted theory of how this belt formed is from the remnants of a protoplanetary disk that never coalesced into a full-size planet due to Jupiter's gravity. After the ship leaves this region, the crew faces many more months until they reach Jupiter. Although the ship is now traveling more than 225,000 miles per hour, there are still about 200 million miles to go. To keep their minds sharp and engaged, the crew has access to various resources, including books, films, and virtual reality simulations. Communication with Earth becomes difficult as they travel farther away. The distance makes real-time conversations impossible because the signal would take 70 minutes to get to Earth and back. The crew's living quarters are designed for both comfort and efficiency. Each member has a private sleeping pod equipped with noise cancellation technology to ensure they sleep well. Communal areas like the dining area and relaxation lounge are designed to foster camaraderie and social interaction. What does the crew do on such a long trip? There would be countless activities, many of which their lives would depend on. Regular equipment checks and system diagnostics are performed to ensure all components are functioning correctly. Advanced AI will reduce the burden as self-correcting systems repair most issues before the crew is informed of them. Finally, the ship reaches Jupiter. A gas giant composed primarily of hydrogen and helium, the planet is covered with magnificent swirling cloud formations that create a kaleidoscope of colors across its enormous surface. The contrast is extreme against the inky blackness of space. From the spacecraft's observation deck, the crew watches stunning scenes of the turbulent atmosphere. They marvel as the clouds dance through the atmosphere, driven by powerful winds and shaped by the planet's immense gravity. The famous Great Red Spot, a massive, persistent storm system that has raged for centuries, is front and center. This iconic feature, larger than Earth itself, is a swirling vortex of high-pressure gas, and its reddish hue is believed to result from chemical reactions in the planet's upper atmosphere. While they study Jupiter, the crew also takes note of its numerous moons, including the 4 largest Io, Europa, Ganymede, and Callisto, known as the Galilean moons. These diverse celestial bodies, each with unique geology, offer a tantalizing glimpse into the worlds that orbit the gas giant. The crew now begins to prepare for a critical phase: orbital insertion. The first step of this maneuver is for the Enterprise to fire its main engine to decelerate and allow Jupiter's powerful gravity to capture it into orbit. This procedure requires an intricate balance of thrust, velocity, and timing to establish a stable orbit around the gas giant. Once in orbit, the spacecraft must orient itself to align with Europa's orbital plane. This is a critical phase of the mission because even a small error could result in an unstable orbit, or worse, a collision with the icy moon. If successful, the ship enters a stable orbit around Europa. This is one of the largest moons, with an average temperature of about minus 260 degrees Fahrenheit at the equator, and even colder temperatures near the poles. In contrast with Earth's moon, it has a thin atmosphere composed mainly of oxygen. However, it's not dense enough to generate weather patterns. One of the primary challenges of a manned mission to Europa is the intense radiation around Jupiter. The planet's powerful magnetic field traps charged particles, creating intense radiation belts. Europa lies within this plane, and any astronaut on its surface would be exposed. This is a big risk to anyone outside the ship and requires substantial shielding. Before landing, the astronauts observe the extraordinary landscape while they're high above the moon. They marvel at the intricate patterns of cracks and ridges crisscrossing its surface, which appear like a vast web of interconnected channels. The ice takes on various hues, from pristine white to striking shades of blue, and even hints of reddish brown, indicating the presence of salts and other minerals. However, when they land, they see the world in its true form: a barren, icy landscape with few visible features apart from ridges, cracks, and icy plains. As they prepare to investigate the subsurface ocean, advanced robotic probes controlled by AI are deployed. These machines are designed to bore through the ice, which can be 10, 15 miles thick. The probes are equipped with cameras that allow the astronauts to observe the ice layers in detail. As they delve deeper, they watch ice transform from a relatively transparent surface layer to increasingly dense and opaque formations. The ice is interspersed with pockets of briny water, indicating the presence of subsurface reservoirs and potential habitats for life. The robotic probes are designed to withstand the immense pressure and frigid ocean temperatures that scientists believe are 40 to 100 miles thick. Even though the Moon is much smaller than the Earth, scientists believe its oceans have twice as much water as all of the Earth's oceans combined. The water covers a fascinating world teeming with geological and potentially biological activity. The underwater landscape is dominated by towering ice formations, hydrothermal vents, and dark, shadowy caverns. The crew hopes their ongoing exploration will unveil the secrets hidden beneath Europa's icy surface and uncover evidence of extraterrestrial life. I know some of you watching will want the answers to whether or not there is life on Europa, but that will have to wait because, at least in 2023, that question remains unanswered. Thank you for watching. If you enjoyed this video, please like, subscribe, and share with your friends. But we're not done exploring. Did you know that 95% of the universe consists of dark matter and dark energy? The visible world around us accounts for a mere 5%. Click on my next video to delve into the most recent investigations surrounding this strange reality. Until the next time.